Alright, so here is our last little lesson for those of you who are trying to get ahead of the game, going from representative particles to mass. So the question is, how many grams are equal to 6.75 times 10 to the 29th molecules of C5H12? First thing that we need to do is to mark up our knowns. And then we need to mark our unknowns. Then we need to look at our mole map. In our mole map, in this case, we are starting from grams, which is our unknown, and we are going to molecules. Other way around, sorry. Our unknown is mass. We're starting with molecules. So we need to take root B and then root A in order to get to mass. So setting up our little drawing or setup. And our unknown is how many grams. I'm going to set this up the same way that I did in the other problems, just because it makes it easy for us to see. Then we're going to talk about our path. If you recall our path, we are going from representative particles, 2 moles, to mass. We need B, and then we need A. And we have to do them in this order. You have to do B first before we do A. So, setting up our conversion factors. Our first conversion factor is going to be B. We know that one already. It's going to be 6.02 times 10 to the 23rd molecules of C5H12 is equal to 1 gram. Sorry, it's getting a little late. Well, a little early at this point. 1 mole of C5H12. Then we're going to do our A. And sorry, for the sake of consistency, let me go back. Alright, so then we're going to go back through this entire process. Our A, in this case, is adding up everything just like we did the last time. So we have 5 C's times 12.01, just 60.05. And then we have 12 H's times 1.008. And that I'm going to cheat and find that is 12.096. Technically not cheating, using your resources since you did a similar problem just in front of it. Then we're going to add those two together and we get, oh, I I see an error. 72.6. Something's not right. So our conversion factor is 72.146 grams of C5H12 is equal to 1 mole of C5H12. And now we set up. Now the mistake that I was talking about was in the last problem. And I'll fix that for you and post it. So our known is 6.75 times 10 to the 29 molecules of C5H12. On the bottom, we need molecules of C5H12. So 6.02 times 10 to the 23rd molecules of C5H12. At the top, the other side. Then we'll use our A, which is moles is at the top, so we need moles at the bottom. And just so we're clear, I did shortchange some things, so let me just clarify. This first part here was our known. This part here was our B. And this part here was our A. So our math is going to be 6.75 times 10 to the 29th times 72.146 divided by 6.02 times 10 to the 23rd. Again, make sure you put those in parentheses when you put them in your calculator, or you'll wind up with the wrong answer. And just looking at this, I have a big number divided by a smaller number. And I did multiply here, so this is an even bigger number. So I should wind up with a number that's bigger than times 10 to the 6th. So if I wind up with a number that's smaller, that's a dead giveaway. And if I wind up with a huge number, that's a dead giveaway. That I've done something wrong and that I need to go back and check my math and see where it is that things went awry. Scientific notation, 8.0. We're looking at 3 places, so that makes that a 9 times 10 to the 1, 2, 3, 4, 5, 6, 7. 7. That doesn't look like an exponent now, does it? So there is our final answer, and it does make sense because this number is quite a few moles, so our answer would need to be quite a few grams. Okay.